Hello everyone, this is Rimsha Mujahid and today we are going to talk about electric vehicle chemistry and its automation system. It's basically revolutionizing transportation system. Let's talk about the transportation system prevailing in our country, in third world countries or the developing countries we have, or the transportation system which we had earlier or decade before. The present transportation system highly relies on the fossil fueled internal combustion engines, that's a fact. And the internal combustion engines are considered as the heart of automobiles. The dark fact of the IC engine based automotive system is number one, the emission of toxic gases, which release oxides of carbon, nitrogen, and unburned hydrocarbons. And we know that these are the cause of severe environmental pollution, which in turn can cause great global warming, which is a major issue of today's world. Internal combustion vehicle impact on the environment during its life cycle is not only during the usage. Remember that the IC vehicle affects the environment during its whole life cycle, starting from its production to the disposal. If we can look here, the carbon dioxide emission during the usage is 85%, while during production or manufacturing it's 10%, and during disposal it's merely 5%. But we can still say that an IC vehicle impacts the whole environment during its usage as well as its production and disposal. It's basically a pie chart here indicating that the global greenhouse gases are emitted by an IC vehicle. And if we can see that there are all of these gases, which are carbon dioxide, methane, nitrous oxide, and other gases, which are the greenhouse gases, and they are the factor or they are the main cause of causing global warming. If we can see here, this is carbon dioxide emission from the transportation sectors merely from the United States, starting from the year 2010 to 2019. If we see here on the x-axis, we have fossil fuel combustion, and on the y-axis, we have emission of carbon dioxide in million metric tons. If we can analyze this graph, it is first declined and then it goes on increasing from 2013 till 2019. So if the carbon dioxide emission is increasing day by day from only a single country, then we can say that the carbon dioxide emissions have been increased all over the world by the transportation sector. Now, what are the advantages of electric vehicles? If we talk about electric vehicles, the automated electric vehicles possess more advantages over human driven electric vehicles. Some of the factors are given, for example, low frequency accidents, high traffic efficiency, and 360-degree vision while driving. Now, let's talk about electric vehicles. Electric vehicles are reshaping the automotive industry and contributing to the sustainable transportation solutions. Now, understanding the chemistry behind the electric batteries and automation systems is quite crucial for advancing this technology. This presentation explores the intricate chemistry of electric vehicle batteries and the role of automation systems in the revolutionizing transportation. Electric vehicles are basically the vehicles powered by electric motors, utilizing energy stored in the batteries. They offer an environmental friendly alternative to the traditional internal combustion engines, and electric vehicles come in various forms, including battery electric vehicles, plug in hybrid electric vehicles, and the hybrid electric vehicles. Uh, some other advantages of electric vehicles that are reduced greenhouse gas emissions, low operating costs, and the decreased reliance on the fossil fuel or the non-renewable energy sources. Electric vehicles basically have a chemistry that focuses on understanding the composition and the behavior of batteries using in them. The primary component of electric vehicles is the battery, which stores and provides energy to provide the vehicle. Different types of batteries are used in electric vehicles, with lithium ion batteries being the most common due to their high energy density and performance characteristics. Lithium ion batteries. Now, let's talk about what are lithium ion batteries. Lithium-ion batteries are the predominant type of battery used in electric vehicles, and they operate based on the movement of lithium ions between the positive and the negative electrodes during charging and discharging. Lithium ion batteries offer advantages such as high energy density, long cycle life, and relatively lightweight construction. Now, understanding the chemistry and structure of lithium ion batteries is crucial for optimizing their performance and longevity in the electric vehicles. Battery electric vehicles. Now, let's define what are battery electric vehicles. Battery electric vehicles use battery powered electric motors instead of the internal combustion engines. The battery electric vehicles are hooked into the charging stations when not in use. And the advantages are high efficiency, zero exhaust emissions, swift acceleration, overnight charging with the cheap electricity. What is the importance of BEVs or why they are important? Number one, the need for alternative transportation. Depleting fossil fuel resources are encouraging the development of alternative transportation systems like battery electric vehicles. While in motors, electric motors are the heart of electric vehicles, enabling their operations. Now, talking about the major battery technologies, we have lead acid battery, nickel metal hydride battery, lithium ion battery, and sodium nickel chloride battery. The major global brands in the automotive sector are immersed in research and development projects to exponentially increase the sustainability of electric powered vehicles. Remember that the world is now working on the sustainability, so it's very important to keep the factor of sustainability in mind while working on any sector, particularly if we talk about the transportation sector. So there exist certain challenges to promote the sale and use of electric vehicles. It should be noted that in many localities, it is still very difficult to recharge these electric powered vehicles, which forces the public authorities to design ambitious strategies for the installation of charging points. And on the other hand, the rapid recharging of these electric vehicles has all attracted, basically, not altered, attracted consumers to purchase and use these vehicles. Also, the cost of electric vehicles is still high, with which even discourages many users to buy these electric powered vehicles. The technological advances in transportation industrial electric vehicles are basically MOS, the metal oxide semiconductor technology, which is facilitated, to modernize the electric vehicle development. The key innovations are MOSFETs, the microcontrollers, and lithium-ion batteries. They have enabled the electric vehicles to travel the long distances. Now, talking about what are fuel cell electric vehicles, let's talk about what is fuel cell electric vehicles. Fuel cell electric vehicle is powered by electricity that is generated. Remember, when hydrogen stored in the vehicle unites with the air, and this type of technology does not produce any type of emissions except pure water. And that's a huge success, I guess. And thus, it can be categorized as green technology. And the world now is working on two things: sustainability and green technology. It is also called a roadside air purifier, as it is capable of removing 99.9% of ultra fine PM 2.5 from the atmosphere. So for fuel cell electric vehicles, the tank that stores hydrogen can have the same capacity as those that stores fuel in an existing internal combustion engine powered vehicle. And its recharge time is similar to filling up with a gasoline at a service station. So we can say that it is not time consuming as well. It is time efficient. It might drastically reduce fossil fuel use and climate change emissions. Basically, the challenges and the limitations we have in this type of electric vehicles are basically the infrastructure, the durability, and the battery lifetime. The few problems these has to be fixed before these vehicles can compete with those with internal combustion engines. But the benefits of this technology could be, huge. So IC engines, particularly in certain temperature and humidity ranges, they are not durable during that. And at that moment, fuel cell batteries only last half as long as they need to for commercial usage. As far as I know, in the past few years, the durability has improved a lot. I think it's going from 29,000 to 75,000 miles. And it's written in the book of The Road to Future Transportation. Uh, However, experts say that these type of electric vehicles need to last 150,000 miles to compete with gasoline vehicles. Well, that's a huge number, I guess. The future outlook is the market growth potential and durability, which we have talked about, that we have to start working on its durability so that we can have these kind of electric vehicles competing with the traditional internal combustion engines. So, battery management systems in electric vehicles. Here are the electric wipes. Let's talk about the battery management systems. Battery management systems play a critical role in monitoring and controlling the performance of electric vehicle batteries, and BMS monitors control various parameters, including the state of charge, state of health, temperature, and these are all to ensure the safe and efficient operation. The key functions of battery management systems include cell balancing, thermal management, overcharge or over discharge protection. Now, this is a very big issue which can arise in that the car or the vehicle can overcharge or over discharge. So the basic purpose of BMS, the vital function, is basically to protect it from overcharging and over discharging. BMS helps maximize battery lifespan, enhance safety, and optimize the energy utilization in electric vehicles. Remember that in this world, we are trying to optimize our energy utilization. We are going to shift towards green energy. We are going to work on sustainability. So all these factors have to be kept in mind even when we are talking about the transportation sector. So automation in electric vehicles, automation systems are transforming electric vehicles by enhancing safety, efficiency, and the user experience. And these systems range from driver assistance features to fully autonomous driving capabilities. Automation technology in electric vehicles includes sensors, cameras, radar, advanced algorithms of perception and decision making. The integration of automation system is paving the way for the widespread adoption of electric and self-driving vehicles. So what are advanced driver assistance systems? Advanced driver assistance systems are a key component of automation, and that is basically, the key feature of it are adaptive cruise control, lane keeping assist, and automatic emergency braking. So the installation of black boxes in the vehicles can help us to understand the reason for vehicle crashes, and also the alcohol countermeasure system would prevent the drivers who have consumed alcohol from driving the vehicle. So, a huge amount of police cases can be solved from this thing. Talking about fuel cell modeling. Yeah, let's just, I have missed something that there's a relation between congestion and road accidents. So, the battery management systems can well deal with all of these. So, ADAS enhances safety, improves driving comfort, lays the foundation for autonomous driving in electric vehicles. Now, the next thing is fuel cell modeling. It's basically a fuel cell in which the hydrogen and oxygen are utilized to generate electricity through the electrolysis process. So we have here the working a little bit, explain the proton exchange membrane fuel cell that consists of 7 layers. That is anode bipolar plates, anode gas diffusion layer. If we can just see and have a look on this picture, we can have the idea of the construction. We have electrical appliance, the field plates which provide the potential, the compressed air which will be having oxygen, nitrogen, and carbon dioxide. The heat will move outwards, the water will move outward. That means that these are the products of the reactions happening. And the next is, these are the construction points. Let's just move towards the hydrogen supply and the processing. Hydrogen is sourced from a reformer and delivered to ABP. And ABP, what is ABP? Well, basically, this is anode bipolar plates, which we discussed in the construction segment. So the anode bipolar plate supplies the hydrogen to the AGDL, that is anode gas diffusion layer, which diffuses into the ACC layer, that is anode carbon catalyst layer. So the hydrogen is broken down into the hydrogen ion and some electrons. Then we have electron and ion flow. The MEA facilitates higher conductivity for ions compared to the electrons, and electrons flow through the fields, the plates which are providing the fields, the field plates and electrical appliances, while hydrogen ions transverse through MEA. So both hydrogen ions and electrons converge at the cathode. Cathodic reactions with the hydrogen and oxygen combine there, and the cathode bipolar plates play a role in this merging process. So we have some hybrid electric vehicles. Let's just have an overview of what are hybrid electric vehicles. Hybrid electric vehicles, basically when a vehicle is powered by both IC engine and an electric motor, that vehicle is referred to a hybrid vehicle. With this configuration, a hybrid vehicle can take advantage of both sources to obtain maximum energy and move economically with excellent performance. These vehicles are partially categorized as green vehicles, but remember, partially, because they have the IC engine combined with them. So we can say them green vehicles partially because they emit fewer greenhouse gases. So as compared to the IC engines, right? One of the main characteristics that distinguish an HV, the hybrid vehicle, is its technology to intelligently manage the power and type of propulsion to be used. An IC engine is incapable of doing that. Remember that. And HV includes several important components that properly regulate its functions, such as an IC engine, generally, the generator, battery, the electric motor, and the computer management system. In most hybrid vehicles, the IC engine, also known as the thermal engine, is either the gasoline or the diesel. And these engines function normally like the existing IC engine that powers the vehicle. However, the fuel consumption of hybrid vehicles is lower than that of any common combustion vehicle. So that's a big advantage. While accelerating the vehicle, the surplus energy supplied by the IC engine is recovered with the aid of a generator and accumulated in the battery. So you're getting that the batteries provide the energy for the electric motor to function. They are usually placed on the rear side of the vehicle or the floor under the rear seats and are supplemented by 12-volt battery, and the vehicle carries to start it. There are lots of benefits of hybrid vehicles, but some of which I want to mention here are that due to combination technology, because a hybrid is basically combination of technology. A hybrid vehicle emits fewer polluting gases since it is not only IC engine. It's We use IC engines here to drive the vehicle, and it consumes less fossil fuels, and that definitely lowers the greenhouse gases, and its mechanism is the one which releases a lot less greenhouse gases. So the fuel consumption is you can say more efficient. The HVs are ideal for large cities, and they allow us to travel long distances while taking advantage of their electrical operation. So we have topologies of fuel cell hybrid electric vehicles. Fuel cell battery plus hybridization, fuel cell plus supercapacitor hybridization, fuel cell plus battery plus supercapacitor hybridization. So these are all the topologies in which we have fuel cell SMES hybridization, fuel cell flywheel hybridization, fuel cell battery photovoltaic panel hybridization. All these are basically the topologies of the hybrid electric vehicles. If we compare all the topologies, that's a very interesting table I have made for you people, so that we can have a quick analysis and quick comparison of all the topologies rather than individually looking on all of them. The fuel cell battery is basically a battery pack installed on a FCEV connected to the DC direct current bus through the unidirectional and by. Let's look at the advantages. It provides the backup power in case of low efficiency zones of the fuel cell. It enables continuous motor operation and allows battery charging based on the charge status criteria. Then we have excellent power ratings and efficiency in fuel cell flywheel. Every topology has their own advantages and disadvantages. We just have to analyze that which type of locality demands what type of advantages and on what type of features we can do a compromise. 100% perfect vehicle doesn't exist, so compromises have to be made. We have to just decide that what on what things we can compromise. We have supercapacitors in EVs. Supercapacitors are developed as the alternative energy systems for future electric vehicles, and they offer high storage capacity. They deliver great power, and some electrode materials are also used in the supercapacitors. And some of it include carbonaceous materials, metal organic frameworks, bimetallic metal organic frameworks, and the transition metal nitrides and the redox polymers. Then we have pros of the supercapacitors based on the energy source storage systems. Definitely, supercapacitors always have power density, better cycle life, rapid charging, holds for low service temperature, and compactness in terms of charging and discharging. Then we have biofuels based propulsion systems for HEVs. Biofuels, are the best option when we want green energy, because biofuels are basically the renewable energy sources. So hybrid plug-in hybrid and extended range electric vehicle utilize the internal combustion engines as one of their energy sources. Biofuels can be adapted for use in the internal engine of these vehicles to reduce the pollution effects and reduce the emission of the greenhouse gases. So this topic is such a vast topic that it cannot be covered in so much small time. But I have tried to cover all the major points, or all the important points or vital points to be included in revolutionizing transportation or looking towards the future. If I basically conclude, or I'll give my concluding remarks or tell you about the future scope, we are at a crucial moment where the global propulsion is global population is continuing to grow, yet economic activity cannot be stopped and fossil fuel decreases inevitably every year. So one of the most significant contributors to air pollution around the world is the transportation sector. To mitigate the transportation's negative effect on the environment. However, it is important to adopt more sustainable, again, see, there's a word sustainable modes of transportation. However, plenty of challenges are prevailing in the alternative system. The electric powered vehicles are said to be green vehicles. We are only just beginning to realize the damage to the environment caused by the extraction of lithium from which batteries are made. So, in this regard, a question may arise whether electric vehicles are 100% green, but when compared to the existing IC engine powered vehicles, the electric vehicles are much more environmental friendly. So, for example, replacing one diesel bus with an electric bus reduces 60 tons of the carbon dioxide per year. So, even if not 100% green, we can say that the electric vehicles are somewhat 80 to 90% green. The slides I have prepared are from two books. One of the books which I really love to read was The Future of Road Transportation, Electrification and Automation. And it has been published in 2023. It's the recent working. And the second book was Electric Vehicles, Design, Modeling and Simulation, and this was also published in 2023. So that's all from my side. If you have any queries, any questions regarding any of the slides or anything, you can just throw us the comment and I'll be replying you with that. Thank you. Take care.